here at our fox hunt here in Murray County Park, and George is going to be using my Yagi to find the fox, and we're gonna have a good day today here. Weather's kind of well, it's good right now. It's a little humid out, but hopefully it won't get any rain. We'll have a good day. But we're getting ready to start the event here. It's actually 10 o'clock. We're all supposed to be here, so I don't know when we actually get started, but I think we're getting ready to go.
This is Keith Herrington here at KQ4FXD. Before we get into the video today, I'd like to cover a little bit of basics about where this video is going. This is mainly for those beginners or those that are interested in doing fox hunting in ham radio. And what this consists of is an RF transmitter that's placed somewhere in an area, and those that are taking part in the event will go out and try to track down that RF transmitter. The transmitter is basically sending out a signal, either a solid tone or beeps or something similar to CW. And you have really no limited time to get it done, but the first one, of course, that gets to the location is the winner. So with that being said, I'd like to go over a little brief introduction of what's going on and what takes place when designing a Yagi antenna or something to trace that signal. Okay, there's a lot of videos on this. There's many videos on the internet that you can look at, and they'll show you how to build an antenna. But if you understand a little more what's going on, I think it'll help a lot in the design itself, and why the elements have to be particular distance and at the right measurement. It's really critical. Let's start with the actual base of the unit itself. Okay, you have a base here. A lot of people make them out of PVC pipe. You can make them from metal, different things, different types of alloy. I made mine out of a PVC pipe, and it works good, and it's just easy to work with and very inexpensive to purchase. It can be however long you want it. It's not critical there, but it is critical that all the elements that are connected to the boom are the correct distance apart from each other, here to here, and so on and so forth. One thing to note, that all the elements on the boom are made up of metal or a metallic conductive type material. They're not PVC, so PVC is not conductive, so it will not work as an element. There'll be a leg here on this element and a leg here on this element, being it is a driven element, and it'll be attached to coax, and the coax will go back to your radio. Now, I would recommend to make it easier to track your fox and to locate the RF source, is that you have an attenuator, and you can buy kits and stuff and build an attenuator that will go in line that allows you to attenuate the driven element, so as you get closer to the RF signal, you can dial it down. You can make it weaker so it doesn't dominate the antenna. Because what happens is, you get closer to your RF source, this thing's going to be picking up signals all around it, either horizontally, vertically. I mean, you're just going to be overrun with signal. When pointing, the director should be in front, leading the way. The reflector, like I said earlier, is 5% usually longer than the driven element. So in this case, 2 meter, 2 meter is 17 3/4 inches on each side. So you want to add 5% to the length of the reflector. It is critical that the distance between the directors, like I said earlier, the distance between the driven and the reflector driven, the distance has to be accurate. So I think out of 2 meter, you're going to be 12 and a half inches, I believe. And like I say, look it up, and you make sure you get it correctly. I believe it's 12 inches here from the reflector to the driven, and then from the driven to the directors, you're about 8 inches. So it's critical that you get that distance correct. If you don't, as your waveform's coming in here, and it's trying trying to hit this for the right frequency, if it's the distance is too narrow or too wide, you'll overshoot it and you'll lose a lot of your gain. So you don't want that. So you want to make sure that the distance is correct. So make sure you get all the instructions ahead of time. So when you leave the location where you start the fox hunt, that you know exactly what you're looking for. If it's a short, like in our case, it was a tone that lasted about 30 seconds, and with a delay of a minute or two in between. So you would have a 30-second cycle, and it would be a tone and then some CW beeps, and then it would shut off for about a minute or two or whatever, and then it would come back on. We were not, well, the noise, well, you'll see in the video, we were chasing a signal that was a lot longer than that, but we weren't listening to the instructions, so that's our fault. But there I think were some instructions that was given ahead of time, and we were setting up some other things and we didn't get all the instructions, so we missed out that part of it. So needless to say, we chased the wrong fox. So don't do that when you go fox hunting. So make sure that you have all the information. Make sure you design your antenna in such a way that it's effective and it does its job and it's in tune. If it's in tune with the frequency you're trying to chase, you'll have a much better time. You'll have more fun in the process. So with that being said, let's get on to the video.